Hello, pharmacy students. It's calculations time with Dr. Dave. Today we're going to look at weighing and measuring of powders by Aliquot method. And this is a useful thing when you have to measure very small amounts, and the amounts that are so small that your balance won't be able to weigh them within the acceptable error that we're looking for. So I think the easiest thing to do is to get started with an example that will describe to you the steps as well as the process and thinking behind doing an aliquot. So if we look at this first example here, the goal that we have is that we want to get 4 milligrams of a drug. That's what we want to weigh. We want to weigh 4 milligrams of a drug. We're going to be doing that with a balance that has an SR of 6. An SR of 6, that means we're using a torsion balance. This is what you'll be having in the compounding lab next semester. And it says we don't want to error in weighing no more than 5%, which is the standard 1 by USB method. So we'll go over the math again about how to do a minimum weighable quantity, but if you did the math for minimum weighable quantity, you will determine that it is 120 milligrams, meaning the smallest amount of powder material that we should weigh on our balance is 120 milligrams to be within 5% error or less in weighing. So because we only need 4 milligrams of a drug, we need some way to figure out this situation. What we will do is that we will weigh out on the balance, on our torsion balance, the smallest amount that we can weigh out with an acceptable error. That's 120 milligrams. That's where the drug is. Then the drug is going to get mixed with a diluent. Diluent is just some inactive powder. In this example, we are demonstrating that as the white powder. So we're going to mix it with a certain amount of this powder. That's going to get mixed together uniformly, and we are going to form this lighter color brown. So the drug is mixed. 120 milligrams of drug is mixed within this dilution. This material, this lighter brown material, is called our dilution. That's the dilution. You can see it right here, the word dilution. We're going to take a certain amount of this dilution. So we don't know how much, but we're going to take a certain amount of this. And when we take away that amount, it's going to have inside of it 4 milligrams of drug. So this amount of powder that we took out from this big pile is going to contain 4 milligrams of drug and a whole bunch of diluent. But inside of that, it's going to be 4 milligrams of drug. As long as this dilution was uniform, and I took out that amount of powder that will have 4 milligrams of drug inside of it, that's going to be above our minimum weighable quantity. The rest of this dilution will actually get wasted. So unless you're making more, you need to utilize that. That dilution will be wasted. So we want to minimize waste, right? The waste costs money as well as a waste of resources. So let's go through the steps of what we do when we do an aliquot. And I have a abbreviation that I usually use when we're doing aliquots. It's MMDD, and you always have one final D at the end. So it's MMDD with one D at the end, and I'll show you what those abbreviations mean. So the first M right here is determining our minimum weighable quantity. So minimum weighable quantity. We know that our minimum weighable quantity is going to be equal, in our case, the SR times the percent error. In our case, the SR, or an electronic balance, we know it's linearity over the percent error. But we know our percent error is 5% error, and we know our SR was 6 milligrams. This was from the question, SR 6 and 5% error in weighing. This came to 120 milligrams. So we know that our minimum weighable quantity is 120 milligrams. Next M that we want to do is the multiplication factor we need to determine. Multiplication factor is simply a whole number that when we multiply it by the amount of drug we need, we get something larger than the minimum weighable quantity. So let me break that down. We take the amount of drug that we're looking for, which is 4 milligrams. We want to multiply this by some number, X. When we multiply it by X, we want that number to be greater than or equal to our minimum weighable quantity. In our case, our minimum weighable quantity was 120 milligrams. So if I was to solve for x here, I know that x can be equal to, or let me take it in a nice color here, x is going to be equal to 30, should say greater than or equal to 30. All we did is we found out that if I take 4, which is the amount of milligrams I want, and I multiply it by whole numbers. And I multiply by 1, I multiply by 2, I multiply by 3, I multiply by 10, I multiply by 20. I'm looking for some whole number multiple that'll get me above my minimum weighable quantity. The minimum amount that we found is 30. We can have multiplied by 100, and 100 times 4 is 400. It's above 120. That would work too, but we want to use the smallest number to minimize waste. Like we said, the bigger the number, the bigger this pile of dilution that's wasted, which we don't want. So now that we found the two M's, right, we have M for minimum weighable quantity, and we have M for the multiplication factor. Now let's move on to our D's. So this first D is going to be looking at the amount of drug. So this D, I'll put the D, this one's drug. So how much drug are we going to weigh out? That's what we want to know. So in order to find out how much drug we weigh out, we take our multiplication factor, which was 30, and we multiply that by the amount of drug that is desired, which is the 4 milligrams. This is exactly what we kind of did above here, right? So we know 4 times 30 is equal to 120 milligrams. This is of the drug. That's what we're going to weigh out. The next D is the diluent. Writing slant is hard for me. D, diluent. All right? That's the white stuff up here. This is the diluent. We take the drug, we add it to a diluent, and we get our dilution. Right? D, D, D. This is what we're going to find out what these are going to be for amounts. So we got our minimum weighable quantity, we got our multiplication factor, we looked at the first D, which is drug. This is how much drug you're going to weigh out. Now, how much dilution, how much white stuff are you going to mix it with in this case, in our example? In this case, you're going to take the multiplication factor, which is 30, right? And this time you're going to multiply that by the difference between the minimum weighable quantity, which is 120 milligrams, minus the amount of drug that we wanted, which was 4. So we're going to take 120, and we're going to minus that from 4, and we get 116. We're going to multiply that by 30, and we get 3,480. 3,480 milligrams. This is what this is going to be. All right. All right. So we now know 2 D's. We know how much drug to weigh out, 120 milligrams. We know how much diluent to weigh out, 3,480. The last D is how much the dilution will be. Well, the dilution is the total amount of the drug and the amount of diluent. So we know the drug was 120 milligrams. And we know our dilution was 3,480 milligrams of the dilution. The total for that is going to be 3,600 milligrams of the dilution. Sorry, this is diluent. All right. So now to go back to our picture here just really quickly, we've got 120 milligrams of drug. We've got 3,480 milligrams of the diluent, and we've got 3,600 milligrams of our big pile here. Now the last question is, how much of this big pile do we need to take away so that we've got 4 milligrams of our drug? So the last thing is how much the scoop is going to be. How much do we take out? We're not going to take the whole thing. We just need to take a small scoop. That's the last thing that we determine, right? Is that we know the concentration. And you can do it different ways, however you want to set it up. If you want to do a ratio, we know that that diluent, right, that big pile of powder, the dilution, has got 360 milligrams in our dilution. Inside of that big pile, we know we've got 120 milligrams of drug. How many milligrams of that dilution do we need if we only want 4 milligrams of the drug? Right? You can also do it quickly if you know your amount of diluent through. So I can do 3,600, right? I've got 120 milligrams. This is the drug times my 4 milligrams. So let's take out our calculator. We've got 3,600 milligrams of dilution divided by 120 milligrams of drug times 4 is going to be 120. So we're going to weigh out 120 milligrams of this right here. This is going to be 120 milligrams. That's how much we are going to weigh out. Inside of that 120 milligrams will be our drug, 4 milligrams, and the rest of it will be the dilution, right? The diluent, rather. All right. Now, keep in mind that there are many ways to do this because usually it involves determining what your multiplication factor is. Remember, we used 30, but we could have used 33, we could have used 37, we could have used 3,000. It doesn't matter what multiplication factor we do, but the larger the number we use, the more waste that we're going to have. So we are in this course are looking to minimize waste. So let's take an example, one more example. Here's an example of saying, how would you weigh 6? Let's look at the next example of how you would do 60 milligrams of oxycodone. So if you want to measure 60 milligrams of oxycodone on a balance, at this time it has an S of 10, and you don't want no more than 5% error in weighing. How do we go about doing that? Let's look at our breakdown. We've got our M, right? Our M, our D, and then our D. And then our last D. So the first one is the minimum weighable quantity. Our minimum weighable quantity is going to be our SR, which is 10 milligrams. Divide that by the percent error in weighing, which is 5%. If we take 10, right, and we divide that by 0.05, we get 200 milligrams. So we know that our minimum weighable quantity is 200 milligrams. How do we get our multiplication factor? Our multiplication factor is going to be the amount of drug that we want, which is 60 milligrams. Right? Then we're going to take that 60 milligrams, we're going to multiply by some number so that when we do, it's greater than or equal to our minimum weighable quantity, which is 200 milligrams. If I take 200 and I divide that by 60, I get 3.3333. Now I can use 3.33, but what we need to use for multiplication factors is whole numbers. So I need to go up. So if I round up to a nearest whole number in terms of being greater than or equal to, so our number has to be greater than 3.33, right? So that number would be 4. If I go to 3, I'm not greater than or equal to, I'm less than. So I need to go to 4. So 4, if I have a multiplication factor of 4, right? That will allow us to be greater than or equal to 200. Now the next D we do, right? So we got 2 M's to do our first D, which is drug. Drug, we take our amount of drug that we want, which is 60 milligrams, and we multiply that by our multiplication factor of 4. Right? So if you take our 60, you multiply that by 4, you're going to get 240 milligrams of drug. This is what you will weigh out in your balance. So you're going to weigh 240 milligrams of drug. Notice it's above our minimum weighable quantity. It's 200, which is acceptable. We're just going to have waste here. So our next one is the diluent, right? The diluent. In order to take our diluent, we're going to take our multiplication factor, which is 4. We're going to minus that from the minimum weighable quantity. In this case, it's 200, minus the amount of drug that we want, which is 60 milligrams. So if I take 200, I minus that by 60, right? And then I multiply that by 4, I get 560. 560 milligrams. This is the diluent. So I'm going to take 560 milligrams of diluent, mix that with 240 milligrams of drug to get my dilution. So this is my dilution. It's 240 milligrams of drug. It's 560 milligrams of the diluent together, right? We get 800 milligrams of the dilution. Now with that, we need to figure out though how much of this dilution to take away. So if we were to take our concentration, which we know that we have 800 milligrams of a dilution, inside of that big pile of powder, it contains 240 milligrams of the drug. If I only want 60 milligrams of the drug, how much of that dilution do I need to take away? So 800 milligrams is our big powder. Inside of that, it's got 240 milligrams. I multiply that by 60, and I get 200. 200 milligrams. And you notice 200 milligrams is of the dilution. So this is what I would take away from that big pile. And inside of that is going to contain my 60 milligrams of oxycodone and a lot of white or diluent powder. All right, let's look at one last example here that is in terms of, sorry, these boxes are weird, but just to keep in mind that when you do mixing of powders, we want that to be uniform, right? In order to do uniform mixing, we do something called geometric dilution. So geometric dilution is when we're mixing powders of unequal amounts, how do we get them so that we can quickly mix them and have the powders be uniform? So if I had to mix 50 milligrams of the drug with 250 milligrams of lactose, this is our diluent, or lactose will be diluent. I want to mix those two powders together. How would I go about doing that? If I have my mortar and pestle, so here's my mortar and pestle. The way in which we do geometric dilution is that you place in the lowest amount of powder you have. So 50 milligrams of one, and I've got 250 milligrams of another. So let's call the drug, this is going to be a big pile of red, and we're going to have the other pile be a whole bunch of pile of green. And this is 250 milligrams, so it's a lot bigger. How do I go about doing that inside of the mortar and pestle? I'm going to take my 50 milligrams of drug, which is the smallest amount of material I have. So the smallest thing I have is 50 milligram drug. And then I'm going to take an equal amount of the diluent. So I'm going to take an equal amount of diluent. So I'm still going to have some amount of diluent. I'm just taking away a little bit. I'm going to mix these up in the mortar and pestle. And then to that, right? So, and then to that mortar and pestle, right, that I have here, it's going to have a big pile of powder. That's going to have the red and the green mixed together now, right? So red and green mixed together. I am going to add an amount that's equal to the amount that I have in there. So I've got 50 milligrams of drug. I got 50 milligrams of lactose. So now I have 100 milligrams of powder. I'm going to take 100 milligrams of this and put it in there and mix it. And now when I do that, I'm going to have a new one that's got 200 milligrams of powder. I'm going to take 200 milligrams of powder and mix that uniformly. And you keep doing that until you're all gone with this pile. That's called geometric dilution. You could just dump the 50 milligrams of drug and the 250 milligrams of lactose and mix that. You're going to be mixing that forever to get it uniform. In order to get it uniform in a quicker amount of time, we use the geometric dilution method for that. Now, there are cases where you might have more than two powders. So if you got 500 milligrams of drug A, you got 1,000 milligrams of drug B, and you got 2,500 milligrams of another diluent, microcellulose, how would you mix those? There's different methods to do that, but usually what you do is you can mix them separately. So you just treat these as if they were two powders, mix them uniformly, and then this mixture you would mix with that bigger amount. Or you can do them all at once where you take 500 milligrams of drug A, 500 milligrams of drug B, and 500 milligrams of the cellulose, mix those together, and do the same concept of geometric dilution. All right. So with that said, this is geometric dilution concept for uniform mixing, but the Aliquot method is what the major focus is for this section. So as always, pharmaceutical calculations is the most important class that you'll have because it's the only one that counts.